Hello viewers, in today's class we are going to discuss a very important indefinite integral, right? So here we have to integrate this function, that is e raised to x 1 plus sine x over 1 plus cos x dx, right? So let us call this integral as I, right? Now in order to evaluate this integral, we have to make use of two important concepts, right? So the first one is to use the trigonometric identities, and the second one is an important form in indefinite integral, right? So we'll see that form in our later discussion, right? So let us first write this integral as e raised to x, and we can split this term, or we can write this term as a sum of two terms, that is 1 over 1 plus cos x plus sin x over 1 plus cos x, right? So once we have written this expression like this, here we have to make use of two important identities from trigonometry, right? So the first one is 1 plus cosine x is equal to 2 cos square x over 2, right? And the second one is the formula for sine x, which is 2 sine x over 2 cos x over 2, right? So these two important identities are to be used to evaluate this integral, right? So we'll now substitute 1 plus cos x equal to 2 cos square x over 2 here and here, and for sin x we can write 2 sin x over 2 cos x over 2, right? So now this integral becomes e raised to x, and here we have 1 over 2 cos square x over 2, and here we have 2 sin x over 2 cos x over 2, and for 1 plus cos x we have 2 cos square x over 2, right? And here we have dx, right? So here we can now simplify this. So we have e raised to x, and here we have half, and 1 over cos square x over 2 is sec square x over 2, right? And here 2 and 2 get cancelled, and cos x over 2 and 1 cos x over 2 get cancelled, so we are left with sine x over 2 divided by cos x over 2, right? And now we can further write it as e raised to x, and here we have half sec square x over 2 plus tan x over 2, right? Because sin x over 2 over cos x over 2 is tangent x over 2, right? So now once we have reduced this integral to this form, now we can make use of an important form in indefinite integrals, and the form it reads like this. Suppose we have the integral e raised to x and f of x plus the derivative of f of x dx, right? So if we have a function like this, where we have the exponential function e raised to x, and these two functions are one of them is f of x and other is the derivative of this function f of x, then we can directly write the integral of this function as e raised to x multiplied f of x plus c, where c is the constant of integration, right? So now we can see here that this integral is similar to this one, right? Because we can take this function as f of x and this function as f prime of x, right? We can also verify it, because if we take f of x as tan of x over 2, then the derivative of f of x is that is f prime of x is equal to half secant square x over 2, because the derivative of tan x over 2 is sec square x over 2, and by chain rule the derivative of x over 2 is half, right? So we see that this integral, right, so this form is similar to this one, right? So because here we have e raised to x, here also we have e raised to x, and one of the function can be treated as f of x, and the other one is the derivative of this function f of x, right? So now we can write the value of this integral I as e raised to x multiplied f of x, right? So now I can be written as e raised to x multiplied by f of x, and f of x is tan x over 2, and we have c as the constant of integration, right? So viewers, this is how we can solve this integral, right? So the important thing about this integral is we have to make use of these two important trigonometric identities, and moreover we have to reduce this integral to this form, right? That is integral of e raised to x, and then we have the sum of a function and its derivative, and the whole integral is equal to e raised to x f of x plus c, right? So here we are not going to derive how we have obtained this relation. We can also derive this relation by making use of integration by parts, right? But here we are directly using this result. So the value of this indefinite integral is e raised to x times tan x over 2 plus c, where c is the constant of integration.